one thing I do want to say about our project is I I really think that a like visualization is so important in debugging, like finding out what's going on um, about your program for debug. Even though like people don't think right now when people think debugging, they don't think visualization at all because they just
Mhm.
think it's like a very tedious process. But
Okay.
in reality when you're doing intense debugging work, what you're doing is visualizing in your head what's going on.
Mhm.
Um, so I think like something like this, like Google Earth, is I think like visualizing code can probably learn from this kind of paradigm of
Okay.
zooming in and zooming out to more and more details and zooming back. The point is you need to have a solid understanding of the program both at a high level and at a low level as well.
Mhm.
And you also need to be able to switch from high to low and from low to high very quickly in some cases.
Mhm.
Um, and I think this is like a very good analogy. And like, I think we should aim for something, so a user interface like this, or like the Mandelbrot set is a similar thing. But that's it.
Well, would you see this as like say a tree, but it's like all collapse, right? And then if you want to drill down to a branch, you can expand that branch,
Yeah.
but normally you don't expand most of
Yep.
the branches.
Yeah. A tree is one way of doing it. Yes, but and it I think is something we should offer or try, but
Uh-huh.
I don't think it's as powerful as this. Um,
Well,
oh,
this is just a different visual of a tree. You will see it, right? I mean, you can move around, but it's still like a tree. And then you can like focus one place at one time and just drill down. I mean, I don't see this like totally different from a tree other than this is a different visual.
yeah, if you
And it's
think of
like building. Yeah.
if you think yeah, when you say tree, it could mean different things. I was thinking the sort of collapsible tree, which is
Yeah.
I mean yeah, this is you can think of the Google Earth visualization as a tree where you're
Right.
zooming towards the leaves when you're zooming in, and then back up. And they actually do represent it like that. They have the images in a tree hierarchy. Um,
Right.
they have like the high resolution image ordered in a tree. Um,
Mm-hmm.
so yeah, so I mean, and this is one way of visualizing, but I think there are other ways of visualizing as well.
Mm-hmm.
Um, so one example I I would like to talk about actually is I ran into a problem where in my JavaScript API server where it was running into this infinite recursion problem, and then we had a Stack Overflow error, and
Uh-huh.
it took me a long time to get to the root problem, but I spent a lot of time on it because
Mm-hmm.
to me it was worth it. I think most
Okay.
developers would probably have like given up and went on to something else, but
Okay.
I stuck with it anyway. And the way I had like it was a slow process, and basically what I did was I came up with I wrote some code in there to kind of to uh, do a bunch of print statements. And eventually, what I ended up doing was generate a visualization kind of like using the
Uh-huh.
print statements. So it was like a recursive function called get objects deep, and then it would receive some sort of parameter. And every time get objects deep gets called, I would do a print statement and then print out the parameter, which might be like, I don't know, some unique identifier. And then
Okay.
I would pass in a level number. Like this is a trick I use often. I pass in a level number, which like at the root level would be 0. And then
Okay.
it calls a child at one level, and I would pass in level +1 to its child
Okay.
call.
Sure.
And then
Okay.
I use the level number for indentation of the log statements.
Right.
So then I end up with, something like this.
Okay.
It looks something like this, right?
Okay. So your goal is to find out which place it just goes, like it just never stops.
Yeah. So what ends up happening eventually is you realize, like one of these branches, like sometimes it'll go back here, right? But obviously, if there's an infinite recursion situation, then one of the branches will never come back to here, indentation wise. So one of them just runs away.
Right.
And but also you can infer that so something like this ended up happening, and one of them is just gonna keep running away. So you will never come back to this point, basically. Once the runaway happens, because it's an infinite recursion, you never get back to this level of indentation anymore. And then these numbers would be different. So I'm just doing copy and paste, so they're all the same, but these numbers would be different. So then just find the cycle. The cycle is like at some point you are calling it with this ID, and then that ID recurs somewhere down the tree. Like maybe over here, the same ID recurred, and then we're back at the beginning of the cycle, and then it's gonna try to do the same thing over and over again, right? So eventually, like it took a lot of sort of trial and error, but eventually I got the log statements to print out a tree like that. And after that, I, because it was still a pretty large tree, the cycle happened within maybe like 60 to 80 lines. Like after 60 to 80 lines, there was a cycle. And then I tracked down sort of the steps to realize where the cycle was, and the cycle turned out to be due to the closures. It was the program that you worked on, the parser. It was due to the actually show you. I think that's like very illustrative of the like some of the debugging problems that people run into that are difficult to diagnose. It's largely a problem of, well, there's a lot of things going on, and you need a concise way to visualize the overall problem at the right level. It's sort of like you want to be at the right zoom level,
right,
to see that. If you're going too deep, then you don't see it. You have to zoom back out a little bit. You have to be at the right zoom level to see what the problem is, right? So that one was.
Well, it's kind of hard to find the level, though. I mean, if you are not very efficient.
Yeah, you do. It's kind of true. I think I don't have a good answer to that. I think other than to say, I think if you have access to a tool, which I'm hoping we can develop a tool that people can use. If you have access to a tool that can allow people to see things at different levels of elevation, allow them to see things switch very quickly from level to level, then they'll just try, right? Until they see the thing that they need to see.
That's true. Yep.
Maybe, or maybe there's a more, you know, precise way for people to find out what level they need to be looking at. Um, but it was basically like here when we called element, then
Okay.
then remember I just implemented the thing that will display the free variables that a closure was pointing to. So
Yes.
when you call element, what is actually happening is, well, element, it actually comes from this sequence call, and the sequence
Right.
call actually is a closure which is pointing
Right.
to these two free variables, which
Mhm.
came from here. So
Right.
when I'm displaying this result, which, what is result? Result is this underscore sequence function, and this
Mhm.
underscore sequence function knows about these two variables, and these
Right.
two variables happen to be, you know, this array and this lambda function here.
Mhm.
And then it's like, okay, if I'm going to look at this array, then I also going to look at this value and this value and this value. And then the
Okay.
problem came when you came to this value. What is a value? A value is a choice, which is also a closure function, and it's looking
Right.
at this guy. And then what is this guy? That's a lambda, and it's looking. It has two closure variables, string and array.
Right.
And what are
Mhm.
string and array? Array is this guy, and then it looked at this thing, and then oh, that in turn looked at this sequence is a closure that knows about this guy. This
Right.
sequence is another closure that knows about this guy, and this guy
Mhm.
knows about this guy. What's elements? Element is a
Oh,
closure
it
that looks at this guy. Oh, we're back at the top. This is
Yeah.
element, and then we're,
Yeah.
we're back at here. So that
Right.
closes the cycle, right? That's what
Mhm.
happened. But this is the, like, I show you the cycle at this level, but when we were going through the code, that it goes through that cycle, but every step is at a slightly lower level than
Mhm.
the level of the code that we're looking at.
Wait, so it's because the cycle that causes like a recursion that never stop.
Yeah, but
Okay.
I had a plan of like using this dictionary of visited flags to
Okay.
stop the cycle, but basically I forgot to do that in one of the
Okay.
branches.
Gotcha. Okay. Interesting. Well, so so I guess, you did a lot of work on like how to improve the debugging experience when you have a lot of closure. I think it's great. Yeah, I think that is have always been um like my issue when I use like a normal debugger. When there are closures, especially like a lot of them, I don't think I can have a great experience of knowing where I am.
Yeah,
So
let
that's
me,
really helpful.
okay. Yeah, I think so too. Like I haven't seen that. Let me show this so that in case there's people watching, they know what you're talking about. I think that can probably work. Okay, so if we go here, is it working? Oh, something might not be working. Okay, if I jump to this line, okay, now it's working. So this is what I was saying earlier, like what is result? Um, oh, we haven't stepped over that line yet. Oh, it's actually no. What is element, I should say. What is element? This is showing you that, well, there's a lot of data. That's another issue that we need to solve, perhaps with expand and collapse. But what's element? Element is the underscore sequence function, which came from here, right? And this is a closure, and has access to these two free variables, parsers and converter, and you can see their value, and the parsers is an array of more functions, which are in turn closures. So it can get kind of crazy, like the amount of information you're looking at, but it's also, and the amount of information we're looking at, again, is a problem that hasn't been solved yet. But if you look at a smaller example like this one, you can see, oh, WS, which stands for white space, is a function of 0 or more characters matching one of these. And that you can actually, like, it gives you all the information right there, right in front of you.
Yep.
The only problem is when all the information right in front of you is too much.
Right. Exactly.
then that's a problem of data visualization. Like, what is the best data visualization for people when they're having to work with a lot of data? And I think that's something that I think is a very like, data visualization is a very important problem right now, given that all these businesses are sort of logging so much data, collecting so much data. A lot of companies are trying to, or either use AI. I guess that's another possibility. Use AI to sort through the data to make sense of the data, or use data visualization to make sense of the data.
Yeah, if you have an AI that can figure out, okay, this ID is like showing up, say, again, and then this is the bug or something like that. Well, sure, whether that's possible.
Yeah, I think there's the ideal is like human computer symbiosis, which means you marry the human and the computer in the most perfect way. and both of the beings are maximizing their ability, but that means the communication between the human and the computer has to be very seamless. And like, the person has to be extremely skilled at operating the computer, right? And using whatever kind of user interface. It's sort of like the Minority Report movie. Have you seen that movie with Tom Cruise?
No.
No? Okay. You should watch that.